Okay, good morning, class. So this is our first session on the derivative of a function. So we have just completed our discussion on limits. So today we will be discussing the concept of the derivative. First, let's look at the concept of the derivative. So the derivative of y, which is a function of x at x equals a, is the slope of the tangent line to y equals f of x at x equals a. So we touched on the concept of tangent line when we discussed limits. So in here, you will see that this tangent line at a particular point, say x equals a, okay, if you get the slope of that tangent line, that slope is actually an expression of the derivative of the curve y equals f of x. Another concept of the derivative is it's the instantaneous rate of change of a function at a point in its domain. So why is that so? Because the slope is actually rate of change. Remember that m is actually delta y over delta x. So it's the change in y over change in x. So the slope is related to the concept of limits in that when you define the derivative is actually the derivative of y with respect to x is defined as the limit of f of x plus delta x minus f of x all over delta x. This expression on top is actually your delta y. So f of x plus delta x minus f of x is your delta y. So it's the limit of delta y over delta x as delta x approaches 0. Okay, so we would want the incremental increase from x to x plus delta x to be as small as possible. Okay, so this is how we define the limit, and from this definition we actually come up with the 4-step rule of finding the derivative. You start by substituting x plus delta x for x and y plus delta y for y. And then after you have done the first step, the next step would be to subtract y equals f of x from the result in step 1, and then solve for delta y in terms of x and delta x. Once you have the expression for delta x, the next step would be for step 3 to divide the result in step 2 by delta x. Okay. Now, after that, then you get the limit of the expression that you obtained in step 3 as delta x approaches 0. Once you have done that, then you have the derivative of y with respect to x. To illustrate, let's consider the function y equals 2x squared minus 3x. And we will be using the 4-step rule in getting the derivative of y with respect to x. So as mentioned in the previous slide, the first step will be to replace x by x plus delta x and y by y plus delta y. So instead of a plain y on the left side, now we have y plus delta y. Then all the x's on the right side will be replaced by x plus delta x. So instead of 2x squared, now we have 2x plus delta x squared minus 3 instead of x. Now we have 3 multiplied by x plus delta x. Of course, the next step would be to simplify this expression by first getting the square of x plus delta x. Using the formula for the square of binomial, the square of x plus delta x is x squared plus 2x delta x plus delta x squared. Minus, by applying the distributive property, we have minus 3 times x is minus 3x. Minus 3 times delta x is minus 3 delta x. And then we further apply the distributive property for the first group of terms. So we have 2 times x squared, so that's 2x squared. 2 times 2x delta x, so that's 4x delta x. Plus 2 times delta x squared, so that's 2 delta x squared. And then we just write the last two terms, minus 3x minus 3 delta x. If there are terms that if there are similar terms, then you combine them. If there is none, you just proceed to step 2. Now in step 2, as mentioned in the previous slide, we subtract y equals f of x from the results that we got in step 1. So on the left side, we subtract y. So previously, we just have y plus delta y. Now we have y plus delta y minus y. And on the right side, we will subtract f of x, or whatever y is in the given. So in the given, y is 2x squared minus 3x. So from the right side that we got from step 1, we subtract 2x squared minus 3x. Okay? So now we have similar terms. 2x squared will cancel out with, okay. So now we have similar terms. So this 2x squared will cancel out with negative 2x squared. And then minus, the negative of minus 3x is positive 3x. So it will cancel out with minus 3x, the one that we obtained from step 1. So looking at what was left, on the left side, y and minus y will cancel out. So we will be left with delta y on the left. And on the right, so we have 4x delta x plus 2 delta x squared minus 3 delta x. So after performing the second step, this is what we have. Okay. Then we proceed to the next step. So that is the expression that we got from step 2. We will divide by delta x. So on the left, we divided delta y by delta x. And on the right, we just copied what we got from step 2 and then divide by delta x. As we can see, all the expressions on top is actually delta x. So we divide 4x delta x by delta x. So we have 4x. 2 delta x squared divided by delta x. So we have 2 delta x. And minus 3 delta x divided by delta x. So we have minus 3. Okay, and for the final step, dy over dx is the limit of delta y over delta x. So all we need to do is to take the limit of the expression that we got in step 3 as delta x approaches 0. So we're taking the limit of 4x plus 2 delta x minus 3 as delta x approaches 0. So we learned how to do this in our previous chapter. So it's going to be 4x plus 2 times 0 minus 3. So dy over dx is 4x minus 3. Okay? So that's an illustration of the 4-step rule. However, you don't need to perform the 4-step rule every time you want to get the derivative of a function, because we have already a bunch of differentiation rules. The first rule is if f of x is c, meaning c is constant, then f prime of x is 0. So this rule simply says that the derivative of any constant is 0. So to illustrate, if your f of x is 5, then your y prime or f prime of x is 0 because 5 is constant. If your f of x is equal to pi, which is another constant, then the derivative of f of x is 0. If your f of x is e, which is also a constant, then your f prime of x is equal to 0. So again, rule 1 says that the derivative of any constant is 0. Rule 2, if f of x equals x to the nth power, then f prime of x equals n times x raised to n minus 1. So to get the derivative of f of x equal to x cubed, applying this rule, we will have f prime of x equals 3 times x raised to 3 minus 1. So you subtract 1 from the original exponent so that your f prime of x is 3x squared. If your f of x is x to the 5th, your f prime of x is 5x to the 4th. If your f of x is 1 over x cubed, take note that if you have 1 over x cubed, this is the same as x to the negative 3. So that your f prime of x after applying the rule is minus 3 x to the minus 3 minus 1. And if we subtract 1 from minus 3, then it becomes minus 4. Okay, so what you can see now for f prime of x is minus 3 over x to the 4th. Okay, so take note that if your exponent is positive, in the derivative, the exponent actually decreases by 1. But if your exponent, if your x to the nth power is in the denominator, then instead of the exponent decreasing, it actually increases by 1. So from x cubed, it becomes x to the 4th. Okay, so yan. And another special case is when you have square root of x. So square root of x expressed in terms of fractional exponent is x raised to 1/2. Again, by applying the rule, f prime of x is 1/2. So that's your n. X raised to 1/2 minus 1. So 1/2 minus 1 is negative 1/2. So the final derivative is 1 over 2 square root of x. So 3 and 4 are actually illustrations of two special cases of the derivative of a power. So if it's in the denominator, it increases. So it becomes minus n over x to the n plus 1. If it's a square root, then it simply is 1 over 2 square root of x. So, now for the third rule, if f of x equals c multiplied by g of x, so that is we have a constant as a multiplier of a function, then it's obtained by simply multiplying the derivative by the constant. So previously, we got the derivative of x to the fourth, and we find the derivative of x to the fourth to be 4x cubed. Now, if it's not just x to the fourth, but 5x to the fourth, you get the derivative by multiplying 4x cubed by 5. So ultimately, your derivative is going to be 20x cubed. Okay? So for 2 over x to the fifth, in the previous slide, we have the derivative. Okay. So this is going to be 2. Okay, 2 times the derivative of x to the negative 5. So the derivative of x to the negative 5 is negative 5 over x to the 6. So multiplied by 2, we have negative 10x to the 6. Okay. D4, so we're into the fourth rule. So this is about the derivative of a sum or difference. If your f of x is expressed either as sum or as difference of functions like g of x and h of x, then the derivative is also the sum or difference of the derivatives of this function. So that means if you have f of x equal to x cubed plus x minus 5, so your function is composed of 3 components. So we have x cubed, x, and minus 5. You get the derivative of f of x by differentiating each term. So first you get the derivative of x cubed. You retain the sign, so plus the derivative of the second term, which is x, minus the derivative of the last term. So all these things were covered already in D3. The derivative of x cubed using the power rule is 3x squared. The derivative of x is 1 because x to the 0 is 1. And the derivative of 5 is 0. So this is rule 1. The derivative of any constant is 0. So that our f prime of x is 3x squared plus 1. D5 is when you have a power raised to a certain exponent. So this is not just x, but a function raised to a certain exponent. So if you have that, then in addition to u to the n minus 1, you will need to multiply n u to the n minus 1 by du over dx. So that if you have y equals 2x plus 1 cubed, then your derivative is going to be 3 multiplied by 2x plus 1 squared. So you decrease 1. You subtract 1 from the original exponent. But don't forget to multiply that by the derivative of the base. So you need to get the derivative of 2x plus 1. Applying d1 to d4, you will get the derivative of 2x plus 1 to be 2. The derivative of 2x is 2, while the derivative of 1 is 0. So the final derivative is 3 times 2, so 6. So it's 6 times the quantity 2x plus 1 squared. Okay. These are special cases of Rule 5. So we'll just call this D5.1. If y equals square root of u, then dy over dx is 1 over 2 square root of u. So this aspect over here is constant. So you indicate that already. So what you will get the derivative of is just the derivative of the radicand. So you multiply 1 over 2 square root of u by the derivative of the radicand. Okay, so to illustrate, if you have y equals square root of 3x minus 5, so you automatically write 1 over 2 square root of 3x minus 5. Then multiply this fraction by the derivative of 3x minus 5. Since the derivative of 3x minus 5 is 3, then your y prime is 3 over 2 square root of 3x minus 5. So some would write, a shorter version of this is going to be du over 2 square root of u. Taking note that du is actually du over dx. So once you have, so let's say you have y equals the square root of, let's say 4x minus 7, your y prime is, so in the denominator, we automatically write 2 square root of 4x minus 7. And then our numerator will be the derivative of 4x minus 7. So the derivative of 4x is 4, while the derivative of minus 7 is 0. So, and then we can cancel out 4 and 2. 4 becomes 2, and 2 becomes 1. So the final derivative is 2 over square root of 4x minus 7. So that's a special case of Rule 5. Then we have another special case of Rule 5. This is when your function is in the denominator. So that is, instead of u to the n, what you have is y equals 1 over u to the n. Okay, so our dy over dx is negative n all over u to the n plus 1, then multiplied by du over dx. Again, a shorter version of this would be negative n du over u to the n plus 1. So that means if you have this, okay, so what you have in the denominator is automatically 3x minus 5 cubed. So you increase the exponent by 1. And then on top, okay, so the exponent of your n originally is 2. So it's going to be minus 2 times the derivative of the base, which is 3. So negative 2 times 3 is minus 6. So let's just illustrate this with another example. Suppose we have y equals, let's say, let's just use 5, applying the other rules as well. So suppose we have 5 over, let's say, x squared plus 1 raised to 3. So our dy over dx, okay, so in the denominator, you automatically write x squared plus 1 to the 4th power. So that's u to the n plus 1. Okay. Then, of course, we copy the constant 5. Multiply that by the negative of the original exponent. So this is 3. So we will multiply that by minus 3. And then, of course, we have to add du. Du is the derivative of the base. So we will add the multiply by the derivative of x squared plus 1. We know the derivative of x squared to be 2x. And the derivative of 1 is 0. So our final answer is 5 times negative 3, which is minus 15. Minus 15 times 2x is minus 30x. So our y prime is minus 30x over x squared plus 1 to the 4th power. Okay. Okay, so we're now into D6. So this is the product rule. If f of x is expressed as a product of two functions u and b, then f prime of x is u times the derivative of b with respect to x plus v times the derivative of u with respect to x. So that if your y is 5x to the 4th multiplied by 2x plus 1 raised to the 3rd power, your dy over dx. So in here, our u is, okay, our u is 5x to the 4th. Our v is the second component, so that's 2x plus 1 cubed. So that our du over dx, applying the previous rule, is 5 times 4, so that's 20 x cubed, that's 4 minus 1. And our dv over dx is 3 times 2x plus 1, using the power rule is, so this is raised to the 2nd power multiplied by the derivative of the base. The derivative of 2x is 2. So this is 6 multiplied by 2x plus 1 quantity squared. Okay? So applying this 6, the derivative of y with respect to x is u. So that's 5x to the fourth times dv. So that's 6 times 2x plus 1 squared plus v. So our v is 2x plus 1 cubed multiplied by du, which is 20x cubed. And then we simplify. 5x to the fourth times 6 is 30x to the fourth. So our first group of terms is 30x to the fourth multiplied by 2x plus 1 quantity squared. Then we just write 20x cubed before 2x plus 1 cubed. Now to simplify, we look for the common factor. For 30 and 20, the greatest common factor is 10. For x to the fourth and x cubed, we use x cubed. For 2x plus 1, we have 2x plus 1 squared and 2x plus 1 cubed. Of course, the greatest common factor is 2x plus 1 quantity squared. So ito yung common factor. This aspect over here is our GCF. Okay. So dividing the first group of terms by the GCF. So that's 30 over 10 is 3. And then x to the fourth over x cubed is x. We totally canceled out 2x plus 1 squared. So in the first term, what's left is 3x. Now for the second term, 20 over 10 is 2. X cubed will cancel out. Our 2x plus 1 is raised to the third power. We only have 2x plus 1 squared outside. So that means we still have 2x plus 1 to the first power left inside the bracket. Then we try to simplify the term here. So it becomes 3x plus 2 times 2x is 4x. Plus 2 times 1 is 2. So 3x plus 4x is actually 7x plus 2. So our dy over dx is 10x cubed times 2x plus 1 squared times 7x plus 2. Now in derivative, we say that it's already in simplest form if the expression is completely expanded or completely factored out. So if you do not want to factor out, guys, then that means you will need to expand 2x plus 1 squared and expand 2x plus 1 cubed. After expansion, you multiply the square of 2x plus 1 by 30x to the fourth. And after you expand 2x plus 1 cubed, you multiply the result by 20x cubed. After which you do the addition and subtraction for any similar terms. Okay, but of course, it's simpler to factor out if it looks something like this because we can see that there are common factors. Okay. And then we have D7. This time, instead of a product, we have a quotient. So we have dy over dx is v times the derivative of u with respect to x minus u times the derivative of v with respect to x all over v squared. So in the example, we have y equals 5x over 2x plus 1. So that means in this example, our u is 5x. So the term in the numerator, our v is 2x plus 1. So that's what you see in the denominator. So as shown in the formula, we need to look for du over dx. Our du over dx is 5. That's the derivative of 5x. Our dv over dx is 2. So that's the derivative of 2x plus 1. The derivative of 1 is 0. Applying the formula, so we have v. So that's 2x plus 1 multiplied by the derivative of u, which is 5, minus u, that's 5x, times the derivative of v, which is 2, all over 2x plus 1 squared. So simplifying, we have 2x times 5 is 10x, 1 times 5 is 5, minus 5x times 2 is 10x. So we cancel out 10x and minus 10x. So our final answer is 5 over 2x plus 1 squared. So that's the quotient rule. Okay. Okay, these are additional examples on differentiation. The application will be D1 to D7. So it's your task to be able to determine which of the rules to apply. So this one is lifted from Peterson, page 69. So we're asked to find y prime given y equals x cubed times 2x squared minus 1. So initially, if you will look at the way y is written, it looks like it's a product. So where u is x cubed and where v is 2x squared minus 1. So if we will apply the product rule, taking u equals x cubed, so that means our du will be 3x squared. And taking v to be 2x squared minus 1, our dv is going to be 4x. Now, if we apply the product rule, our y prime will be, okay, so that's u, our u is x cubed. We will multiply x cubed by dv, so that's 4x, plus v, that's 2x squared minus 1, multiplied by du, which is 3x squared. So simplifying, so again, it's either completely factored out or completely expanded. So x cubed times 4x is 4x to the fourth. 2x squared times 3x squared is 6x to the fourth. Minus negative 1 multiplied by 3x squared is minus 3x squared. We can combine 4x to the fourth and 6x to the fourth, so that our final answer is 10 x to the fourth minus 3x squared. So this is what we got by applying the product rule. But there is a shortcut to this, because as you can see, our y is x cubed. Our y is x cubed. So let me use a different color. Okay, an alternative solution will be to simplify the y first. Okay. This is actually a better solution. It's shorter. So if you can simplify your function first, so that instead of using the product rule, what we can use is just the derivative of sum and difference. Because you can simply multiply x cubed and the quantity 2x squared minus 1. So x cubed times 2x squared is actually what? 2x to the fifth. Minus x cubed times 1 is actually x cubed. Now that we have already simplified the given function, we can get the derivative of y with respect to x. So the derivative of 2x to the fifth is 10 x to the fourth minus the derivative of x cubed is 3x squared, which is the same as what we got when we used the product rule. So the lesson is, if you can simplify the expression, it's better to simplify the expression before taking the derivative. Okay. Unless, of course, there are restrictions. So you will have to specify the restrictions first. What are the restrictions? Like in rational. Okay. Like this. So you have y equals 2 minus x times 2x plus 1 all over x. So we can simplify this by making the restriction that our x is not equal to 0. If that is so, we can just what? Before taking the derivative, we expand 2 minus x and 2x plus 1 and then divide each of the results by x. So this is what you will have if you will multiply 2 minus x by 2x plus 1. Using the FOIL method, you will have 2 times 1, that's 2, minus 2x. Minus x times 2x is minus 2x. Then we have 2x times 2 is 4. X, 1 times minus x is minus x. So that's going to be 3x. Okay, sige. Gawin natin. So first term, so that's 4x. Outside, 2 times 1, that's 2. Inside, that's minus 2x squared. And last terms, minus x. And then combine like terms. And then rearrange. I arrange it in ascending order because the exponent, the coefficient of x squared is actually negative. So I opted to arrange it in ascending so that the answer is 2 plus 3x minus 2x squared all over x. Since the denominator is simply x, we can just distribute x to each of the terms in the numerator. So that 2 over x is still 2 over x. 3x over x becomes plus 3. And minus 2x squared over x is minus 2x. So now that we have this, instead of doing the quotient rule, we can just simply apply d2. So 2 over x, the derivative is minus 2 over x squared. The derivative of 3 is 0, and the derivative of minus 2x is minus 2. So remember that if your function is in the denominator, instead of decreasing, exponent actually increases. So this is 1. So the exponent is minus 1. So multiplied by 2, so it's minus 2. And we simplify the result by taking the LCD. So that's x squared. So we have minus 2 minus 2x squared, and then factor out minus 2. So it becomes minus 2 multiplied by 1 plus x squared over x squared. Now, if you are differentiating in terms of specific value, say you are asked to find f prime of 1, you don't need to simplify. You can just simply plug in 1 in your y prime so that it becomes minus 2 over 1 squared minus 2. So minus 2 over 1 is minus 2. Minus 2 minus 2 is minus 4. You don't have to simplify like this. Because even if you will not simplify, you will still get the same answer. Now, if x equals 1 will be substituted in the simplified form of the answer, then you will also get minus 2 times 1 plus 1 squared over 1 squared. So 1 squared is 1, added to 2 is, added to 1, it becomes 2. So negative 2 times 2 is minus 4. And of course, we know that 1 squared is 1. So negative 4 over 1 is still 4. So kapag yung may specific value, you don't have to simplify. Once you have differentiated it, you can immediately substitute the value of x. Okay, so that's it. Now let's have another one, again from Peterson, 5y prime for the given value of x at x equals 1/4. Okay, so again, we have y equals x plus 1 over square root of x. So instead of using the quotient rule, which is what you would normally do because this is expressed as a quotient, but since the denominator is just a single term, meaning a monomial, it's better if you simplify the function first before taking the derivative, so that your y becomes x over square root of x plus 1 over square root of x. We know that x over square root of x is square root of x. Why is that? Because the exponent of x in the numerator is 1, while the exponent of x in the denominator is 1/2. Okay, so suppose you have x cubed over x. Then this becomes x squared. Why x squared? Because 3 minus 1 is actually 2. So what we do is we subtract the lower exponent from the higher exponent. And since the higher exponent is in the numerator, the remainder or the quotient will still be in the numerator. So we have 1, and then we have 1/2 in the denominator. So if you subtract 1/2 from 1, you get 1/2. So yung x to the 1/2 will remain in the numerator because nga the exponent in the numerator is higher. Now yung 1 over square root of x is still 1 over square root of x. There's nothing you can do about that. So once you have simplified your y, so then you take the derivative. So square root of x is actually a special case. If you take the derivative of square root of x, it becomes 1 over 2 square root of x. So this is x to the 1/2, right? And it's in the numerator. So it becomes what? If it's in if the term is in the denominator, then the exponent is actually negative. So we have 1. Okay, so this is 1/2. Then you increase the exponent in the denominator. So instead of just 1/2, this becomes 3/2. So 1/2 plus 1 is actually 3/2. So this is actually 1 over 2. Let's just use fractional exponent. Minus 1 over 2 x raised to 3/2. Okay, so since there is a specific value, so we can just plug in 1/4 without simplifying this expression. So the next step would be to substitute x equals 1/4. Okay, so if we substitute, what we'll have is f prime of 1/4 equals 1/2 square root of 1/4. So that's 1/4 raised to 1/2 minus 1/2 1/4 raised to 3/2. So square root of 1/4 is 1/2. Okay. So square root of 1/4 is 1/2. What is 1/4 raised to 3/2? Knowing that the square root of 1/4 is 1/2, the next step after getting the square root would be to raise that square root to the third power. So if you raise 1/2 to the third power, it becomes 1/8. So the 2 here will cancel out with the 2 such that our first term is going to be what? The 2 will cancel out. We'll just have 1 here. Then 2 and 8 will cancel out. Ang matitira dito, 1/4. So since we have a fraction in the denominator, we need to get the reciprocal of that fraction. So this becomes -4. Is that clear, guys? So we have 1 minus 4 minus 3. So the final answer is -3. So again, what happened is the 2 canceled out. So we have 1 in the first term. The 2 and 8 canceled out. So instead of 1/8, it becomes 1/4. And you know that if you have a fraction, say 1/2, this is actually the same as 3/2. So we take the reciprocal of 1/4 because it's in the denominator. The reciprocal of 1/4 is 4. So that becomes 1 minus 4 minus 3. Okay? So yun. And then we have, okay. This one is about the chain rule. Okay, now we go to the chain rule. So the chain rule is when you have a function expressed as y a function of u and u a function of x. So dy over dx is the product of dy over du and du over dx. So as an illustration, we have y equals u squared plus 6u minus 8 and u equals 3x squared plus 6x. To differentiate this, we need to find dy over du. So that's dy over du. So taking the derivative of u squared, we have 2u. Plus the derivative of 6u is 6. Okay. We can factor out 2. So this becomes u plus 3. But this is still in terms of u. What we need is something in terms of x. So the next step would be to substitute the value of x, which is 3x squared plus 6x. So that in our dy over du, what we'll have is 2 multiplied by 3x squared plus 6x plus 3. Now, if you look at all the terms inside the parentheses, we can clearly see that there is a common factor. And that common factor is 3. So we can take out 3 from the terms inside the parentheses and multiply that common factor by 2. So that what we'll have is 2 times 3, it becomes 6. And what remains inside the parentheses is x squared plus 2x plus 1. Now, if you can recognize x squared plus 2x plus 1 being a perfect square trinomial, we can factor this out and express this as 6 times the quantity x plus 1 squared. Okay, so here we just factored out 3. So it becomes 2 times 3 multiplied by x squared plus 2x plus 1. That's why instead of 2, we now have 6 in the next step. So this is our dy over du, but we need to compute also for du over dx. So du over dx is the derivative of 3x squared is 6x plus the derivative of 6x is 6. Again, we notice that 6 is a common factor, so we factor out 6 and then multiplied by 6x over 6 is x plus 6 divided by 6 is 1. So we have 6 times x plus 1. Okay, so applying the formula, so dy over dx, so for our final step, is the product of dy over du, which is 6 multiplied by x plus 1 squared. Then multiply that by du over dx, which is 6 multiplied by x plus 1. So our final answer is 36 multiplied by x plus 1 cubed. Okay, so that's D8. Next, we have D9. Okay, so in D9, we have a parametric equation. Your y is a function of u, and x is also a function of u. So dy over dx will be a function of u as well. Okay? So you get dy over dx by dividing dy over du by dx over du. Okay? So given that your x is 2u cubed minus 3u squared and your y is u cubed minus 3u, so all you need to do in applying this parametric formula is to find dx over du. So the derivative of 2u cubed is 6u squared minus the derivative of 3u squared is 6u. Okay, we can factor out 6u so that 6u squared over 6u is u minus 1. So this is our dx over du, but we need to find dy over du also. Dy over du is the derivative of u cubed is 3u squared minus the derivative of 3u is 3. So again, we factor out 3. So we have u squared minus 1. So finally, we apply the formula. Dy over dx is dy over du. So we copy 3. Quantity u squared minus 1. Now, being aware that our dx over du actually has u minus 1, we can actually express u squared minus 1 as u plus 1 times u minus 1. So that when we plug in the formula, the value of dx over du, so we copy 6u times u minus 1, it will facilitate the cancellation of u minus 1. So we cancel out u minus 1. So ang natira, we have 3 and cancel out 3 and 6 as well. So 3 becomes 1, 6 becomes 2. So our final answer is u plus 1 over 2u. So that's applying D9. Okay. Now the last formula is for the basic differentiation rule is finding dy over dx when it's x, which is a function of y. So instead of y being a function of x, we have x expressed in terms of y. So you get dy over dx by just getting the reciprocal of your dx over dy. So as in this case, we have x equals 1/3 y cubed. So what we need to do is to get dx over dy. So the derivative of 1/3 y cubed is 3 times 1/3 is going to be 1. So that's y squared plus the derivative of y with respect to y is 1. So that our dy over dx is 1 over y squared plus 1. Okay. So that ends all the basic formulas for differentiation. So these are additional resources which I hope you will visit for additional examples on differentiation.